This is a construction for given a line and a point not on the line, construct a parallel through the point not on the line. So we're going to do the construction, but I'm also going to explain why the construction works. So first of all, we need to get our tools. We need our compass, we need a straight edge, and I like to have two colored markers for my markings. So let's talk about what we're here to do. We're going to start off with given a line. So we have a line, take my straight edge, and I make a nice line. And I'm going to put arrows on each end and give it a name. I'm going to call this line A. And then we have to have a point not on the line. So I just pick any place I want. I'm going to put right here, this point here, point P. And what I'm here to do is to construct, using my tools, some line that's going to go through point P that is parallel to line A. Now, of course, there's infinitely many lines that could go through point P, and I can't just eyeball it and say, well, that looks good, because nothing in geometry is as it looks. It has to be proven to be so. So what is it that we're going to use to do this? And it might not seem like this is the right thing. You might not see that, oh, that makes a lot of sense at first. But what we're actually going to do is we're going to do copy and angle construction. That's what we're going to do. So what this is built on is the following theorem. It's the converse of the corresponding angles theorem. And what the converse says is that if you've got two random lines and a transversal, and they create corresponding angles that are congruent, then the two lines that you had to begin with must be parallel. We didn't start off with them being parallel, but because the corresponding angles are congruent, I know the lines are parallel. This is the theorem we're going to be using. So what we need is, well, we're going to be creating the second line, but we needed the transversal, and the transversal is going to go through point P and intersect line A. We have lots of options of how, we could try to make it where it's, perpendicular, but we just be eyeballing it. I like to do it where it's going to create down here an angle using line A and this transversal that's going through P. I like it to create angle 1 that's acute. It's just an easier construction when I have an acute angle. Doesn't have to be, I could have chosen this angle over here, but this is the angle I'm going to copy. Angle 1 is what I'm going to copy, and I'm going to copy it up here, meaning I'm eventually going to have a line here where this angle, angle 1, and this angle, which I'm going to be calling angle 2, are congruent. And if those two angles are congruent, then these two lines must be parallel. So how do I do that? It's a copy and angle. So once I had this line that went through point P and intersected line A, it intersected at this point, which I'm going to call Q. Okay, that's the point of intersection. That's the vertex of angle 1. And what I'm going to do is I'm going to copy angle 1. To copy an angle, we're going to need our compass. So we want our compass to be open a comfortable distance, about that. And I'm going to construct circle Q. So I'm picking a radius. That's what the compass is doing. This is the radius of my circle. I put the foot of the compass at the center of the circle, circle Q. And I'm only going to draw part of the circle. I'm not going to draw the whole circle just because I don't need the whole circle. I'm going to construct just the part of the circle that intersects the two sides of angle 1. So there it is. And so this is the radius of circle Q. And it intersected the two sides of angle 1 in two places. And I'm going to give those names. This is going to be X and this is going to be Y. Those are the 2 points of intersection on the sides of the angle. Keeping my compass open the exact same radius, I'm going to draw a second circle where the center of the circle is point P. So I put the foot of my compass down at P. And then once again, I don't need to draw the whole circle. I'm only going to draw the part of the circle that intersects both that pink transversal and past where I believe the other line's going to go. So I made a nice long arc. Now, what happened was when I did that, this distance from Q to X and this distance from P to here, they're the same distance. That's the radius of the circle. And both of those had the radius, the same radius, okay? It also means that this was X. I copied that, and that's X prime. That's what I did, okay? Now that I've got that, what I'm going to use is my compass to measure from point X to point Y. So putting my foot of my compass on X, since that's the one I have both points of, put the foot of my compass at X, and I want to measure, open my compass exactly to Y, and when I get it open exactly to Y, I'm going to mark the diagram by, again, making a little bit of the circle that goes through Y. So that shows you, oh, this is open, that distance, which is from X to Y. And I'm going to transfer that distance up here to where I'm copying it, putting this at X. And I copied that there, and that means this is a copy of Y. So this is Y prime. And just like this went Q through Y, I need a line that's going to go Q through Y, actually P through Y prime. So carefully lining them up, P through Y prime, draw a nice line like this. And this angle that I just created, angle 2, right here, that's a copy of angle 1. And since angle 2 is a copy of angle 1, I know that they are congruent. They are the same size and shape. So I can say angle 1 is congruent to angle 2. So this is what I constructed. And why does that make this new line that I just constructed, which I'm going to call line B, why does it make it parallel? Because the corresponding angle converse theorem tells us that when you have two lines, and here's just two lines with a transversal, and we created two congruent corresponding angles, then the two lines, A and B, must be parallel. So I can say, therefore, which we didn't have in the beginning, I've got line A parallel to line B. And that is constructing a parallel, this B, we constructed a parallel to line A through a point P that was not on A.